Hello and welcome back to College Algebra, MAT 150. In this lecture we're going to be discussing how to graph logarithmic functions. So we use logarithms a lot, and in particular we're going to use logarithms with a base of e and a base of 10. And logarithms have to have a base, but we're going to use these bases quite a bit. However, we use them so much there's a shorthand for both. So if you see ln of x, that is a logarithm with a base of e. So when you see ln, think this. Same with logarithm. So they have to have a base, but if we don't see a base, we have to assume the base is 10. All right. So with those being said, we note that if we have f of x equals to e to the x, then its inverse is g of x equal to ln of x, because logarithms are logarithms and exponentials with the same base are inverses to each other. And we can construct the graph and learn how to graph logarithms based on the inverse, trying to construct an inverse for e to the x. So what's true about functions and their inverses? So if you have e to the x and you have ln of x, so this is your f, this is your g, we have the point 0, 1, and we have the point 1e. And what's true about functions and their inverses? Well, logarithms, or the points swap, the x's and the y's swap. So instead of 0, 1, we would get 1, 0. Instead of 1e, we would get e1. Also, we have a horizontal asymptote of y equals 1, or y equals 0, excuse me. And then we swap the x's and the y's, and we would get x equals 0, which turns this from a horizontal asymptote into a vertical asymptote. So we have the vertical asymptote of x equals 0. We have 1, 0, and we have e1. So again, e is about 2.7. So 1e, or e1, excuse me. And then it's got to look like this. Again, it's symmetric about the line y equals x, so it should fold over. So that would mean that this would then look like this. Again, note that the end behavior for the around the vertical asymptote is only true at one side. So we can't obviously go up on both. And that's always been true for vertical asymptotes, but it's just kind of interesting to note. All right, so we have this base graph for our logarithm for g of x. As it turns out, this idea can be extrapolated further, just like we did with the exponential. So we have f of x equals ln of x. We had that. Notice that the base was e, so we had 1, 0. That's the case for all logarithmic graphs. We also have e1. So for any logarithmic graph, log base b, again, b is just going to be greater than 1. So any logarithmic graph with b greater than 1, we're going to have 1, 0. And we're going to have the base is b, the output is 1. And then we're going to have a vertical asymptote at x equals 0. So we do this, b1, or 1, 0, and b, wherever b is, question mark, 1. We get something like this. All right, so with this idea, we now have a basic idea of how to look at logarithmic graphs. So because of that, for base logarithmic graph, we can also do transformations to these graphs. So what's the base graph here? Well, since it's a ln, logarithm, a log with a base of e, then we have a base graph of of ln of x, which again gives us 1, 0, and E1 in the vertical asymptote of x equals 0. All right, and then we have the lines, we have this, and what we're going to do is we're going to then connect it. Oops. Just like that. So this is our base graph. But now we also need to deal with the transformations. So there's a negative in front. So there's an x. So when it's outside, again, the inside would be inside the parentheses of the logarithm, inside the argument. But the negative's on the outside, so we have an x-axis reflection. We also have plus 3, which means we shift left 3. And remember, the transformation we always do last are shifts. So we're going to do that last. So we're going to deal with the x-axis reflection first. So that means it flips over this axis, which means it negates our y values. So it goes y to negative y. So instead of 1, 0, that's, well, guess what? It's still going to be 1, 0. We're still going to have a vertical asymptote of x equals 0. But instead of E1, we're going to have E negative 1. So it would be like this, and the whole thing would flip, and we're left with this. Further, we have inside this the plus 3, so we're going to have to shift to the left 3. So again, since it's on the inside, it affects the x values. So we take our x's, and again, we do the opposite of whatever it's telling us. We subtract 3. So if we're subtracting 3 from all x's, this also includes the vertical asymptote. So we would take away 3 from 0, so it would be x equals negative 3. So we have that. Instead of 1, 0, it's going to be and E negative 1. So it's going to be negative 2, 0. And remember that this is about 2.7. So when we take away 3 from 2.7, that's about negative 0.3. So about negative 0.3, negative 1 would be our other point. And this is negative 2, 0. And we just connect it. And this is our graph of f of x. All right. That concludes everything from this graphing portion.